Anyone who's worried about last week's meteor and asteroid will be glad to know Canada is doing its part in trying to take the surprise out of those kinds of events. NEOSsat, or the Near-Earth Object Surveillance Satellite, is set to launch tomorrow. It's meant to be an early warning system when things drift a bit too close to home. And we built the satellite itself, that being Canada. We played a big role, a major innovator on this project. Bob McDonald is the host of CBC's Quirks and Quarks, and he's our favorite space guy. We've reached him via Skype in Victoria. Hi, Bob.
Good morning. Well, I guess it's afternoon
Good
for you,
morning
isn't
for
it?
you, yes. A bit of a time difference there. Tell us a little bit more about what this satellite does. What kinds of things is it designed to find?
Well, this satellite is entirely Canadian, designed by Canadians, built in Canada, and it's only about the size of a suitcase. It's about this large. I could actually hold it here in my hands if I wanted to, but even though it's small, it's very powerful, and it's going to be looking for asteroids, objects that go around the sun along with us, the Earth, as we go around. And it's going to be looking for those that are on the inside track. So if you think of the Earth going around the sun as like a racetrack, Mars is on the outside, and there are a lot of asteroids out there, but there are also some on the inside, and we don't really know much about them. So that's where it's going to be looking both ahead of us and behind us to see who's flying around the sun with us, and if any of those have our name on them.
That's incredible. So that's exactly how it works then, if you can go into a little bit more technical detail.
Yeah, well, the way it works is, the way you find asteroids in general is that you just look at a piece of space, and in this case, they're going to be looking fairly close to the sun, just beside the sun, because that's as we're going around it. You're looking ahead on your track. We know where the stars are. So all of the constellations that you're familiar with, like the Big Dipper, the Little Dipper, Orion, those patterns we know, and they're always the same. If there's an asteroid, it'll be moving in front of those stars. So what you get is a little streak on your picture. And you can tell by that streak which way the asteroid's going. You can tell how big it is. You can tell even its chemistry. You can tell a lot about it just by looking at those streaks. And you watch them over a period of time and see how it's progressing. So they'll be doing this in a very, very detailed way, both looking ahead and looking back, to just try to get a count of how many are out there, because we don't know. They suspect there are just thousands and thousands of them there, but we just don't know where they are. And that's the first bit of information we need in case one is heading our way, so then we know what to do.
Right, that's the big question mark. The events last week, of course, many people still talking about that meteor exploding over Russia and the asteroid whizzing just past Earth, certainly raising the questions of whether we have a strong enough detection system. But what happens if NEOSsat does detect a real threat to Earth? Is there some kind of plan?
Well, there isn't much of a plan at the moment, actually. The way they would do it is NEOSsat would predict the orbit very, very accurately, and they would be able to tell when and where it's going to hit. So they might say, okay, it's going to hit in Toronto on a particular day at a particular moment. And then they'd have to evacuate the area, which would be a rather difficult thing to do. The other thing, if they can catch it early enough, if we know a couple of years before it gets here, perhaps we could send a rocket out to meet it and not try to blow it up. You don't want to blow these things up because you go from having one object heading towards you to having 100 objects heading towards you. But the most crude idea at the moment is to actually send up a nuclear weapon. And we certainly have a lot of those lying around.
Yeah.
But take one and you blow it up beside the asteroid, not on it, but beside it. And the radiation and the pressure from that explosion would nudge it just a tiny bit. You don't need to move it very much, just a tiny bit. Because when you're really far away from your target, it doesn't take much of a move to miss the target. And the Earth is a pretty small target when you view it from a distance. So at the moment, that's about the only thing we could do. But so far, nobody's done anything like that. And it's going to be very interesting to see if we can do that quickly.
Yeah, let's hope that they'll be working on it. Thanks, Bob.
Okay.
CBC's Bob McDonald with Quirks and Quarks.